Hi everyone, now I'm going to explain how this fault detection method is working. First of all, you need to make sure following the README file and following the steps to end up to running the web server. After running the web server, so you will see the same page as I'm seeing, and you can run some specific sample for test your models. So I'm going to start testing with some test for video clips. I can select any of those. For example, I can select maybe this one. Could be a nice example. So you load your video and then you will see the rest of the options will show up. If you train the models in your repository, you will have these models available in your setup, because the train checkpoint is going to the proper directory and these buttons will check the right address. For example, I trained my model in TCN ResNet with fault and non-fault video. Now I'm going to test this. So what's happening first, the model raw data going through the YOLO 11 pose extraction, then comes up the skeleton to goes through the CNN model. Here you will see the activity being detected in this purpose. Because this CNN model just been trained for this 6 activity, they're not able to detect fault. So then it just said, okay, it's just someone is working. But if you train the model, I think as I mentioned, this model being trained. Now this model being trained for these two model all these model trained on the KTH dataset, which includes 6 activity, but these are the models being trained for fault and non-fault. But non-fault being considered as a KTH dataset, and for fault we have some fault samples for training the model. Because without having, for example, non-fault samples, the training is not completed. So you see the model detects the fault properly with 94% accuracy, and the same could happen for the other CNN model or the BIT model, and so it shows that deep learning model is working properly over these fault detection tasks. Now what I'm going to introduce is a model called VLM model for fault detection, which doesn't need any training set, which means with 0 shots, without any training samples, model can detect activity, which is in this case is fault. But yes, it's not been trained for fault detection, but there are some prompt kind of or context engineering happened, which we tune the output of the model based on the prompts for fault and non-fault. We have a set of fault and we have a set of non-fault prompts, which we encoded, and then compare the result with these two sets, see how they are similar to fault or non-fault, and take that as a fault or non-fault class. The other model we have developed, you see the accuracy of 50 something. The other one is 0 shot, few shot, which been trained, which is a kind of trained 0 shot model on top of with a thin layer of training, BC training, which trained by some specific samples. So what's happening is, again, you can see some level of accuracy for fault detection, and just as example, we come up with some annotation and some kind of subtitle of the each frame per second. You see it comes with person lying, a person lying on the ground, and all of this together end up to this overall description. And comparing this overall description, comparing with the set of fault and non-fault, we could conclude to fault, for example, in this case. So that's all about this video. But for example, if you, as I mentioned you initially, the model on the top models been trained for example, let's select one of those maybe running, a bit more challenging. So train on the 6 activity. So this is just I'm going to run activity detection for these 6 trained model with the trained dataset, comparing to VLM model with zero shot, which there is no training set. So it detects running by, accuracy of 59, probability of 59, and jogging and walking and following with much lower accuracy. And you can see I detect this as jogging. So that's all about a brief about this activity recognition and fault detection with VLM model in this repository. You can find more details in the paper and the repository with following the codes. So don't forget to train each model separately and test them as well. And there are some other anomaly detection models which you can use as well in the